thank you very much for inviting me to speak to you again. So that's twice you've had a geologist to the most, which is pretty brave. You might regret it. Can you hear me okay? Yeah. I also want to thank Sans for being brave enough or kind enough to associate themselves with the books, two of the books I've written, the last two. That's really, you know, it really helps sell the books, and as the books will ultimately hopefully produce some money for Sans, that's a good thing. But it's allowed me to know several people in this room much better over the last few years. You could be forgiven for thinking that the books are coffee table books for lay people, but that's not specific enough. They're for non-geologists, so it's for youth. I don't care whether you have 50 years and experience as an archaeologist, they're for you. They're written in simple but not necessarily simplistic terms. And over the last few years, I've come to understand how little I, as a geologist, my peers, understand about your area of work. And of course, how little you understand about my area of work. I do. Right, I've got three now. And my wife says I don't need one. So that's not encouragement to buy the book. Yes, it is, but it's basically an introduction to some of the slides you can see tonight. Because you didn't know this, you haven't just come here to hear about the connections between geology and prehistory, but it's a bit about the connections between geology and archaeology. And people ask me why I do these things, and for the last couple of books, the hidden agenda, it's not very hidden, is it, is I want to start a conversation about the inclusion of geology and archaeology. I think it's long overdue from what I do, and I'll be providing the evidence for that this evening. So here's the premise. If prehistoric society's major asset, stone, rock, and their most persistent record, after all there is no inscriptions, unless you include rock art, why do we know so little about them? And I ought to caveat what I said earlier. It's not just, I'm not having a dig at archaeology. I don't think my science does anything to go into what is essentially no man's land between our two disciplines. And I think ultimately the loser is what we know about archaeology and about the use of geology in archaeology. So Don was about to read a long bio, which thankfully I asked him not to. So this is me. I worked for nearly 20 years as a field geologist in Cumbria and the South Northumberland coalfield. And I messed with computers in the 80s and 90s before the words GIS or ArcInfo or any of those. Was responsible as a result for transforming BGS's analog data into digital form. And you probably don't know what British Geological Survey is, but it's spent roughly £60 million of your money every year, employing 550 PhD and master's qualified geologists, and has a rock store that's bigger than any Amazon store you've ever seen. So, and has terabytes of data and 47,000 maps. So it's a big organisation in terms of one small subject. And I retired in 2011, and now I'm becoming great in your last name, I guess. You know, I'm the person who loves what your subject is, archaeology, and got more and more interested, and a little knowledge is the dangerous thing, so I've pursued a bit more of it. So there you go, there's the there's the statement, this is what the talk is about. If you want to understand prehistoric societies who are completely reliant on the natural world, how can you understand it if you don't understand what sustained them? And then the more controversial bit, to all those of you who are principal investigators and kick off projects and put in proposals or audit those things, are you really, really sure that you shouldn't involve a geologist if one of the fundamental elements is geological? And I would argue that most of prehistory is, unless you consult a geologist at the beginning and in the middle. Not that he has to be the main man, just that you ask them. And let me digress for a minute, because I know Don's in the audience, and I've told this tale to David Breeze. On Saturday, I went to a Hadrian's Wall networking event in Hexham, and I was asked to go and look at a beehive quernstone, which had a label in front of it that said, this is a Mayan quernstone, and as a result, we know it came from Germany. We know the regiment that brought it over, and there was this incredible narrative. And I said, but it's a piece of Criffel Dalbeattie granite. Oh, they said. On the basis of one rock, all of that narrative had developed, and it was a wrong identification. It wasn't a difficult identification to make, because the difference between Criffel Dalbeattie granite and a vesicular volcanic rock is quite fundamental. Even an undergraduate could do that. But a whole house of cards was built out of one misidentification. We could do others. We could do the fabric of the frontier and Roman wallstone, but we won't go there because this is about prehistory. So this is my photo, because I love digging for Britain. I love watching, screaming at the TV. Look, this is one of my maps. It sits in as an easel, and these guys are from the Carlisle dig. And everything on that table is my business. It's a rock. Where did it come from? And if you don't know where it came from, how do you know what its narrative, what its contribution to unpicking the sociological and political stories? So I want it to be more than a pretty prop in the corner. Although you wouldn't be unusual. The chief scientist at DEFRA once asked me for a geological map for behind his desk. I said, do you understand it, Robert? He said, no. He says, but it's very colourful. That is a true story. So this is the way it's going to go. A quick, all on the same page, introductions to why rocks and ancient societies go together. An appraisal of us, me and archaeology, and then the core of the talk is the evidence of the connections between geology and prehistory in the north of England. So it doesn't take a great deal of imagination to understand that primitive people, their relationship with their landscape was intimate. Not for them. They didn't have Amazon delivering stuff to their door, nor Northern Power Grid restoring their power. Everything they had to understand the landscape and take advantage of it, whether it was for shelter or for making fire or for understanding where to grow their crops, which was wet, which was dry, where to source the right sort of stone to grind things. That's topical, isn't it? So all of those things, they depended on the landscape, and the landscape is largely influenced by its geology. So these are just a few of the things that prehistoric people used rocks and geology for. And you don't have to read the small print. We'll go through them. When they first came here, I guess not the first time, but late Upper Paleolithic. Those are three words I couldn't put together before last year. They were dependent on rock for shelter. This is Kirkhead Cave in southwest Cumbria. They depended on it for almost every implement they had, whether it was a hammer or a cushion stone or striker lights or a flint blade or jet buttons. everything they used, even if it was organic, they needed something inorganic to process it, whether that be the flint for skinning it or a stone for beating it. So almost everything they depend on is rock. And of course, what we know it best for is the way that they use rocks and stones as part of their ritual. And this maybe comes to the most contentious part of this presentation, because arguably, rightly or wrongly, you can't go far nowadays without the most important prehistoric monument in the country receiving yet another piece of wisdom about how it was built and where its rocks came from. The other point is there is no Roman inscriptions of Great Britain for the prehistory. Everything, all the evidence we have is in rock, whether it's bits that stick up or bits that stretch. And so, unless you know the geology and the landscape, how can you put a coherent and cogent picture together of and interpret what these things mean if you don't know where they're from or what they're made of and why they're valued? So let's have a look at us. Sorry, I'm just broad sweeping you all. I'm painting you all with an archaeological brush, but you are members of SANT. So, and I'm your sole geologist, either stupid or brave or both. What we share is an incredible passion for our sciences and about the past. We're all curious about the past. We go in the field, we do the same things, we look, we measure, we survey. Landscape and rocks are absolutely central to our disciplines. We overlap in those things. We even share vocabulary, although we use them in subtly different ways, but we have stratigraphy too. Our stratigraphy came long before your stratigraphy, but that's neither here nor there. We talk about provenance. Where did things come from? Our curiosity is perhaps in a different way to yours, but nonetheless, we want to know where things came from. We're fundamentally interested in where the stone came from, whether it be these rocks at the Devil's Arrows, which are 100 meters from the A1 in Burbridge, or a piece of Cunnion Crags that seems to have found its way into a top of a post hole in Wiltshire. All those things are of interest to us, and we look at it from a different angle. But the complementary angles, we geologists are really interested in flint, but our curiosity is about how did it actually originate? And we've argued about that until very recently. We continue to argue about the origin of flint. For us, that's flint, by the way, is just cryptocrystalline silica. You can call it a back blade, Paleolithic back blade if you want, but it's just a piece of flint to us. And the difference between flint and chert, we have a definition which we think is scientifically sustainable, but we are very suspicious of your separation of flint and chert. We care about metals, but we're worried about the ores. Where did they come from? Where did they get the copper? Where was the tin? Did they really know how they made brass? So we share these areas of curiosity. You wouldn't get far with isotopic work if you didn't have a geological map. It's okay sending it to the NERC isotope lab and saying, give me a multi-atomic analysis of this, which they do to high resolution. But guess what happens then? They compare it with a geological map and the geochemistry of the UK, and the geochemists of the UK go next door to speak to people like me, who's a geologist, and say, can you tell us what the spatial limits of that bit of rock are? And I say, well, I can, but just remember my science is interpretive and I could be 2 kilometers out here. They never tell you that when they give you your isotopic result, do they? So we share those things. You depend on the other bit of the system. the minerals in the rocks get caught up in the water we imbibe, it gets hung up in our teeth, in our dentition and in our bones. So we can roughly tell you where you come from, provided we've got enough contextual data to match your analysis with the geographic location. We've both grown to love LIDAR and geophysics, haven't we? Even though Tony Robinson can't pronounce it, it's not geophysics, it's geophysics. But ours is kilometers deep and yours is shallow and much higher resolution. But we both use the same techniques. And as I say, we love LIDAR. This is maybe the most crucial thing we share. Our sciences are interpretive. There is no such thing as a fact in geology. There is just the latest interpretation. Our data, we claim to be quite systematic and coherent, and yet it's fragmented and it's very variable and it's subtle. So forget the Grand Canyon. Britain doesn't look like that. Go and have a look at the Town Moor. See if you can see a rock. And yet somebody had to produce a geological map of that. It was Muggins. But the picture on that side, that's somewhere in Cumbria, whose name I've forgotten, but it's some sort of henge, I think. But even though you go there on the ground and it hardly shows, neither do the coals and sandstones and siltstones that run across it. So these are subtle things, and we have to acknowledge that everything we do is interpretive. But we are different. So this is your time scale, everywhere from the late Quaternary 2.6 million years ago to the Iron Age, 2,000 years ago-ish. But let's put them in perspective. That's mine. Just a bit different. So we're looking in the north of England, at least nearly 500 million years, and your focus is 2.6 million. So you'll forgive us if sometimes our calibration is, does a couple of million years really matter in the great scheme of things? But I'll add to that. We've got one thing you haven't got. We've got a systematic contextual base. We've got geological maps of the whole of the country. 47,000 of them at 1 to 10,000 scale, several times. So if you go out and drill a borehole on the Town Moor, a couple of boreholes maybe, or even open a trial pit, you will be able to go to the geological map to contextualize that, to understand whether you're dealing with something that's anomalous or consistent. Set that against archaeological excavation. And that map of Great Britain makes it look darn sight more populated than it is. It's just that the person used big red dots. Your information is incredibly detailed. We do not take paintbrushes out to clean rocks. We just take a hammer, which means we shouldn't be allowed anywhere near scheduled monitoring. But you lack that context. So your joining of the dots can sometimes force on you interpretations they have huge confidence limits. My work can go from the quite detailed, predict the geology along the line of the Tyne Weir interceptor sewer. That was one of my jobs when I had an honest job, to looking at the way the Earth works, just how far away is tectonic drift in the Central Atlantic Ridge taking us away from President Trump. It's a centimetre a year. So we do the big scale and the small scale. You guys have got this real big challenge. You try to weld two things that are not necessarily great bedfellows: science and social science. The humanities with science. And that, I think, is my heart goes out to you, because I don't think those are two parts of the brain that work together well. The ability to be creative and imaginative, and the other to be controlled and constrained and only go as far as the facts will allow. And that human variable that you deal with is incredibly volatile. You impute and infer what people did and people think. Whether that be what happened to Burns' work, or just what colour and what was the background to those people who first came to Britain with the Romans and ruled it. Those are shades of grey. So you've got an incredible challenge that geology as a rule doesn't have, because it doesn't have the human variable. So what's the evidence for all those assertions, apart from the difference and the similarities between our disciplines? I'd like to do it this way, if I may. The books look at it in terms of freeze and thaw, the last glaciation, settlement and defense, implements, ritual. But if it's okay by you, I'm going to cut it the other way. So we'll go through the matrix in chronological order. And we'll do it through around 20 places across the north. I don't know whether we'll get called to the pub before I get to the end, but you can time me out if you want. I don't know how much you know about the last part of the last glaciation. Don't use the word ice age. We're still in the ice age. That's an Alice Roberts mistake. She makes it every week. We're in the ice age. We're just in a warm bit of it. We're in an interglacial, yeah. So the last glaciation reached its peak about 23 to 20,000 years, but I broadened it to 35 to 18,000 because we keep changing our minds in geology. We're like that. And how do we know there was a glaciation here? What's the raw evidence, apart from you trusting the word of a geologist? Well, you only have to go to the Lake District to look at the U-shaped valleys and the arêtes and the tarns to realize you're dealing with an alpine landscape. And if you want to know, well, what happened on the lower ground? Here's a classic erratic. I don't know whether, I know you'll need inoculations and a visa to go here. It's North Yorkshire, but it's worth going. I mean, this is Norba above Orstwick, and this is a wonderful erratic. It's Silurian and it's sitting on Carboniferous limestone pedestal. And what's really interesting about this is that this is Carboniferous limestone. Nobody put this here. This isn't one of those Welsh, whatever they call them, that they have in Pembroke, where this is natural. This is Silurian grit, and this is Carboniferous limestone. This is 35 centimeters tall. And on the basis of this, we know that that limestone pavement lost 35 centimeters in 15,000 years. It used to be complete. That rock sheltered that bit, stopped it dissolving. Just to add a bit, this is a bit of detail that I wouldn't normally add, but so we're talking about this last glaciation, and we're looking at 700 to 1,000 meters of ice covering the whole of the north of England down to almost York, down to Manchester, into Wales. And it's important that you understand that we don't understand everything, but we know that there were different dynamics and different vectors in that ice sheet. It didn't just happen once and do that. It changed. So here's it was 30,000 years ago. Coming down the Irish Sea, coming down the North Sea, going south down the Eden Valley and round the Tyne Valley. 20,000 years ago, what's changed? You notice that? Does it matter? I mean, how does he know these things? How do they know these things? Oh, basically, erratics, and where the distribution of rocks moved by the ice sheets, the topography, the things called drumlins, which is their stoss end and which is their lee end, because they're asymmetrical in shape. That's why we know these things differ. Does this matter? Well, these are stone, these little dots are stone circles or stone monuments. It matters because if the ice is so dynamic, and this is just one of 4 glaciations that we know about, there were another 3. The oldest we know about is 475,000 years ago, called the Anglian, that could have moved stuff about even more. I'm driving at where did the stones from the stone circles come from. Can you see it could have come from Criffel Dalbeatty over the Solway, down, bring it all the way down here and into Yorkshire. It equally, in the latter part, could have brought Shap granite all the way around there. It's like having a larder that's constantly restocked at different intervals. You can move, I once heard a guy last year talk about the West Stainton bypass and how he'd got stone from Arran, pitch stone from Arran, microliths, and chert from up here, and Langdale axis and this Mesolithic site. And he said, it's a definite social network. It's trading. And he'd done a lot of work on it, and I'm sure he's almost right. But I was stupid enough to ask the question, have you completely excluded natural agency? Yes, that's a digression. Well, I'm sorry. I can get every one of those stones there into the Solway Plain without touching a human hand. So you might be right, but keep an open mind. There is no such thing as certainty in science, and no good scientist is ever certain. So this is the work of a guy called Les Knight, retired geologist like me. We're dangerous, we do stupid things. Like he's identified Shap granite erratics. These are all the Shap granite. You know Shap granite. You've seen it every time you go in a metro station. It's the rock they use. And the reason it's picked out is because it's really obvious. You cannot miss Shap granite. You would not misidentify Shap granite. We'll come to that later. Look, it's down here, Anglesey. It's even on Cleethorpes Beach. It's everywhere. You can see how those ice sheets moved the stuff about. And this is only Shap granite. Think of the rocks that we struggle to identify, the Windsill, or Carrickfell Gabbro. All of these would be good indicators too, but they're less easy to recognize. This one is in your face. So people pick it. Les is not the only one. There's a whole bunch of retired geologists who go map erratics around the country. Okay, let's go back. 15,000 years ago, the climate was ameliorating. The ice sheets had gone. We'd had a few thousand years of thaw and tundra and mosses, and then slowly vegetation returned, dwarf willow, dwarf birch, juniper. It depended where you were, how high and how low you were, and what the aspect of the country was, but it revegetated. And then 12,900 years ago, give or take 100 years, this is good for geology, until 11,700 years ago, there was a cold spell. The ice sheets came back south as far as the Solway, just about. They didn't get into the lowlands of Cumbria, but they did start. The cold snap meant an ice cap in the Lake District. And not all those, if any of you go walking, all those little moraines you see in the upper reaches of the Seathwaite Valley or the Langdale Valley or the tarns you see, they weren't from the big glaciation, the main Devonsian. They were from this little cold snap where ice started to gather again. And then almost as soon as it came, it went. And we don't really understand why, but it did. So we were clear of ice in the high ground at 11,700. But of course, one of the consequences of that incredibly thick ice sheet taking over most of the northern hemisphere was that sea level had dropped to 120 meters below the levels we know today. And it slowly recovered. There are two opposing forces work at sea level. One is isostasy and the other is eusostasy. One is the melting of the ice sheet means there is less weight on the land, and the other is the rising of sea levels. And they sometimes act in opposition. They don't usually synchronize. And the hinge line, just to make it difficult for us around here, is pretty much Solway to the Tweed. That's where everything north of that is rising and everything south of that is sinking at the moment. So sea levels are difficult. But if you wanted to see evidence of that, you only have to go for what are called fossil submerged forests, that are either here at Amble or in the Solway at Beckfoot or down at Barrow-in-Furness or Hartlepool. And 6,000 years ago, you could have walked from Hartlepool to Haarlem. I don't know why you'd want to do that, but you could. Well, maybe you wouldn't want to do it the other way around, Haarlem to Hartlepool. But so the shape of this country was different. And the real Brexit happened about 6,000 years ago, not in 2016. So people returned. Initially, as we were just a peninsula of northwest Europe, they could walk across. And the late Upper Paleolithic people, the first evidence we've got are caves in Yorkshire and in South Cumbria, and rock shelters where they occupied it and shared it with bears and aurochs and a host of other mammals. The piece of evidence we've got in the northeast is sitting in the Hancock Museum. It's a back blade on the basis of the shape of the flint. Specialists regard this as being evidence of late Upper Paleolithic, and it was picked up near Prudhoe in a field walk. I mean, there are other reasons it could be there. It doesn't have to be late Upper Paleolithic. It could have come from some period before or been dropped. But nonetheless, that's the first evidence I could find of the return of humans, because make no mistake, humans were here in mild periods between other glaciations. And you'll probably have heard that, they found evidence of fire being made 500,000 years ago near Heathrow. So every time another year goes by and we get an earlier occurrence of humans in Britain, but for us in the north, post-Devensian glaciation. We go to the Mesolithic, and I'm picking up a piece of Clive Waddington's research because I liked it. And I liked the fact, and I don't know Clive that well, and he hasn't paid me, but I love the fact that he got geologists and physical geographers involved in that piece of work. So he understood about the Millfield Plain, and he understood about the deltaic terraces coming out the Glen Valley over here. And that helped him do better at his field walking and direct it so they would pick up the best chance with limited resource and time of where to find the best evidence of Mesolithic nomadic people settling around the lake or hunting in the cheviots in the summer. So this was a fantastic multidisciplinary approach as far as I would see, and ahead of its time, and one I thought I would read about again and again and again. But I don't. So I know I'm a Cumbrian, so forgive the bias, but so we're in Langdale, and this is, you all know it, it's a Langdale axe. Or is it? Are you sure it came from Langdale? This is Piker Stickle, the Langdale axe factory, although I know that I'm not supposed to call it that, was there, down in that gully. I've never had the courage to go down. This is, I mean, if you were an antiquarian, you'd be calling it something like hornstone or greenstone. Now, in archaeological circles, it would be called a tuff. It's not. It's a Seathwaite sandstone formation. Okay, I know geologists call things weird. This is not a plain ordinary tuff. It's a siltstone with silicious cement. Its origin was in incredibly fine ash from the volcanoes that existed 450 million years ago, that went up tens of thousands of feet in the air, floated gently down, completely monolithic, all the same particles, pretty much volcanic glass, going into the crater lake, and then becoming a sediment. This is not a true tuff. It's a volcaniclastic rock. What's more, it's not unique. Just because there's a band of it here that's been called the Langdale Axe Factory, you can find this same rock on Glaramara, on Scafell, in many other places in the lakes. There's this assumption that it always comes from Langdale. But people have been incredibly friendly and open and charitable and to us, an ignorant, I was going to say innocent, ignorant geologist. So I spoke to Jamie Quatermain, who with a guy called Clarice did the seminal work on mapping out, surveying where the Langdale axe came from. He said, well, it was a self-fulfilling prophecy. We were told only to look for a band 20 meters thick across the fells. Did you look above it or below it? No. So how do you know that these axes all came from Langdale? I mean, Richard Bradley, the doyen of a lot of Neolithic work, his theory is that it isn't about the rock. The rock doesn't matter. What matters is the inaccessibility of that place. That's why they work the rocks there. And do you know that's curiously consistent with the geology, because the rocks are not unique. We could go to a lot less accessible places and pick up that same rock and produce the same axe, and you wouldn't know the difference. But it just highlights to me the continuing reinforcement of what might be a very weak statement. First of all, the lithology is not a tuff. It's a volcaniclastic sediment. You notice that geologists we try to put things in buckets and then we realize that they don't fit, so we have to have a merged bucket. We could call it volcanosedimentary. This one's Duddo. I thought I'd better put a Northumberland picture in just to get on your good side. So it's all sandstone, fell sandstone probably. This is not rock art. These are natural runnels. They're erosion through 10,000, 12,000 years of natural weathering by rain. The rocks are 90 degrees to their original horizontal bedding. They've been erected at 90 degrees, thus their weaknesses and bedding is vertical. You don't have to invent, as people have with the devil's arrows, that somebody who spent loads of time sharpening blades or carving these things. There's if in doubt, use Occam's razor. Think of the common sense explanation. Why go for a sophisticated one unless you want a PhD or a bigger citation indice? Right. I know it's in Cumbria, but I bet you've all been here, haven't you? You know it well. It sits in a beautiful amphitheatre. How about if we go back to Neolithic times, before they'd started to clear the woodland, and we adopt the theory of, I can't remember his name. It's not Vera, because he was the one with the glades. The guy who said it was closed canopy woodland. How much, if we plant 25-meter trees all around this, how much of this wonderful amphitheatre do you think would be visible for this stone circle? Well, I can tell you, I used some augmented reality and I planted a forest there, and you can't see Blencathra, let alone this fell or that one over there. So, was it forested? Was it cleared? Did Neolithic people leave Castlereagh in a forest, or was it this wonderful amphitheatre, and that's the reason for this? It gets worse. There's a brand new book out in 2024, Richards and Cummins, A Field Guide to British Stone Circles. Castlereagh has X number of stones. They're all metamorphic slate. That would be, I can't think of an archaeological equivalent, but it's a complete tautology. All slates are metamorphic. And worse, they're not metamorphic slate. They're all Borrowdale volcanic rocks. So, does it matter? Well, if you don't know what rock it is, how can you say where it came from? And if you don't know where it came from, how do you know what the agent was that brought it there? Was it people or was it the glacier? And how do you know if you start erecting theories about its astronomical or calendrical symbolism? How do you know that it's a microcosm of the landscape if you don't know what the rock type is? This is all Borrowdale volcanics. To the north, Skiddaw, Blencathra are all Skiddaw slates. It makes no sense to try and resolve what is a very difficult challenge anyway of trying to infer the reason and the how people took this there, unless you understand one of the basic attributes of this circle. It's bloody stone. Ask a geologist. They'll be only too pleased to tell you. And look, on the basis of that and looking at Long Meg and her daughters, and in that book I chose to use Swinside and another one called Gunnerkeld in Cumbria, and I went to visit them. And I looked at all of the antiquarian and Burl and I've forgotten his name, another guy, but Cummins and Richards' book as well. Swinside, 60 metamorphic slates. No, 100% volcanic rock. Castlereagh, we've done 100% volcanic, not metamorphic. Gunnerkeld, 60 red granite monoliths. 3. And Shap granite is the most obvious rock. Long Meg and her daughters, rhyolites. No. Some of them are lavas. Some of them have come from Criffel Dalbeatty. Some of them have come from Threlkeld. And the big one here, Long Meg herself, comes from a cliff near the River Eden. Shap Avenue. Shap granite. No. Most of them are Borrowdale volcanic. Now, forgive me, but how much effort and money and research goes into trying to find whether Stonehenge's blue stones, where they came from? You've got the best of geochemistry and mineralogy and physical geographers and others putting together all that information. Then you've got lots of archaeologists with pretty big reputations complementing the other half. One stone circle, and it's 100% human moved. That's what the received wisdom is. No natural agency. You've got another 999 stone monuments in Britain, and we don't know anything about them. We just assume. Back home, places you have been. Rock art, Roughton Lynn. I can see why people think that one's definitely anthropogenic. This one, I think, probably was a set of those runnels, and some Neolithic person thought, do you know, I love the way the water runs through these natural channels. I'm just going to augment it a bit and make it run better. I'm not saying that's what did happen, but I'm pretty sure that most prehistoric societies took their inspiration from nature and understood it and watched it better than we do, and would have known what they wanted to copy or what they wanted to augment. So be careful when you assert that this is all Homo sapiens is doing. I think the sapiens is a bit doubtful nowadays, but anyway. Here's you're above the, God, forgotten the name of the valley, Breamish, and you walked up to Canyon Crags, which is a piece of the Cheviot granite. That's the coast over there. Beautiful bit of granite. And look what they found in a West Kennet, top of a West Kennet post hole. A piece of Cheviot granite, well rotted, well it would be, it's travelled a long way. How did it get there? It's well beyond the limit of the glaciation that moved the furthest, which was the Anglian, which almost got to the Chilterns and Buckinghamshire. Was it carried all the way? Do we know what we know about the limits of the last glacier, of the Anglian glaciation, and not the limits of the glaciation? They're the limits of our evidence. Those two things are different. So keep an open mind when you hear Mike Parker Pearson say this Preseli bluestone came from that exact socket in the Preseli Hills. Well, I could take you to the Roman wall and show you exactly the same thing, a piece of dolerite that looks just like a Preseli bluestone that hasn't been quarried at all. It's all the result of columnar jointing in that rock and the weathering since. That's the way that dolerites look. And what upset me more about that was that he got primetime TV with a TV producer and presenter saying, this is it, cut and dried, all done. Well, it's a reasonable hypothesis, but please don't make it certainty. You're completely dissing a lot of respectable geologists who think there's some doubt there. And you're not doing your science any good either. There's no such thing as certainty in science. Don't tell me something's cut and dried. You're only going to change your mind tomorrow. You did with the altar stone. Bronze Age. Loved going up here. Rob Young gave me this recommendation to Crawley Edge. I mean, what's it got to do with geology? Probably less than some of the other things, but the stone clearance was wonderful. What I couldn't work out was why Bronze Age people would choose to settle in such what is now an inhospitable place with incredibly thin soils. And why did they leave so suddenly? And why did they leave everywhere else so suddenly? In Cumbria, there's a place called Barnscar with about 600 field clearance cairns, some of which have become burial cairns. And about the same time, people left. Was that climatic deterioration? Was it exhaustion of the soils? Was something else involved? I don't know. This is me indulging myself, just loving going to places there. Yeah, I envy you for being able to go. Back in the northeast, you'd be pleased to know, we're up at Slaggy Ford at the Kirkhoff Barrow. And so there were two barrows there, and they were both excavated in 1935. And they found all those things that are in the Great North Museum. And they found one gold hair tress in 35, and they found a hammer stone and a cushion stone and a flint blade and some jet buttons. And the reasonable story, I think it's Andrew Fitzpatrick? Does that ring a bell? Andrew Fitzpatrick, his theory, and I spoke to him, and he said, the best thing I can think of is this is a Bronze Age metal prospector or craftsman in metal. Because his body wasn't preserved. There wasn't even a greasy stain on the limestone. So although there were these goods, the best thing I can, and this one here was 35, and this one was found by 4 schoolboys in the community archaeology project in 2016, 17. But I love it because it's all rock. And I like his story too, because this stuff up here is malachite and azurite from just not very far up the road in the Pennines, because the Pennines is rich in copper ore. And I like the story of this guy coming from elsewhere, because these gold hair trussel things seem to mean he was a man of status or distinction. And coming along to Bronze Age people and saying, I know they won't know what copper is, but I bet they know where some green stuff and blue stuff is. And I like that conversation. What I loved even more was this. One piece of pyrite and one flint saw blade about the size of my finger. That's a fire making kit. It's a striker light. We would not have evolved if it hadn't been for rocks. You try rubbing two sticks together in a temperate climate, it doesn't get you very far. So there's a couple of pieces of rock that moved us on to being Homo sapiens. Even further into the northeast, Hastings and Seven Sisters, there's only 5 now. Somebody's pulled a couple of the trees down. But I was intrigued by not so much the grave goods here or the skeleton, although that was a nice picture to have in the book. But it was the construction of the tomb and the choice of rocks, because there's a piece of whinstone in there as well as the magnesian limestone. And I kind of felt that the geological influence on the Seven Sisters is that it's one of these tombs, like many Bronze Age tombs and cairns, that's not on the top of the hill, it's on the false summit. So you can see it from below, but it's a bit like walking in the lakes. You know, you think you've reached the summit and then you've got to go a bit further. But you can see that, I mean, Rob Young was at great pains to point out to me that he felt this was a statement about territory as well as remembering your ancestors. This is our land. I can look, there's my granddad up at the top there. And many of the places I visited to research the book had that same flavour, whether it would be Rosette Pike over in near Kirby Stephen, or Castle Carrick Fell in Cumbria. They all had that same relationship with the topography, which is based on its geology. So we moved to the Iron Age at last, and Don did tell me that the closest I was going to get to a prehistoric expert tonight was late prehistory. So this, I'm sorry, very little about it for you guys, but Warden Hill near Hexham, Humbleton Hill, the geological basis for this is layer cake carboniferous stratigraphy, a series of hard and soft sandstones that provide Warden Hill. Humbleton Hill, it's the glacial drainage channels that isolated it, that provided its seclusion, that made it a strategic place, whether for Iron Age or for Neolithic people who were there before, or even Henry the whoever, or the Scots who defended it. I remember asking Nick Hodson if he could point me at any Iron Age places I could include in the book that were visible, that I could take a photograph of, encourage people to go and see. And I know it wasn't easy, because the low ground tends to be very much changed by what we've done to it in agriculture and urbanization. But I tried at the time, when I was looking at the Roman stuff, to include Stanek, because I was fascinated by it as an enormous, great settlement, oppidum, palace, whatever, meeting place. And when I went to visit it, I was even more enthused because of these rock cut ditches. And why was it there? You know, I know it's at the crossing point of the North Road and the route over Stainmore to the west. And then, of course, they found the Melsonby Hoard, and I suppose my first thought was, well, that stuff doesn't look very irony. It looks more like copper alloy to me. And encouraged that there was an awful lot of copper material. Why there? And when the Scotch Corner improvement went through, there was more evidence of limestone that had copper mineralization. There already was at Middleton Tyres, which is only a couple of miles up, if less, than the Scotch Corner roundabout to the east. 60% rich coppers, all staining the limestone green. Really obvious to people. Were they working it? The person who did, the archaeologist in charge of the 2011 bypass work, said he hadn't got any definitive proof, but he thought it was pretty powerful that some of the things, evidence they'd seen in the cuts into the Great Limestone and the copper staining was evidence of working. And I thought that was really positive, because otherwise, where are these people getting their copper from? Where are they getting their iron from? Are they getting it locally, or are they shipping in from Alderley Edge or the Great Orme? This is Tolland Man, so he's in the Silkeborg Museum. Sadly, I had to use his photograph. Do you know getting a permission to use a photograph from a Danish museum was 7 months faster than getting permission from English Heritage for a photograph I took myself in Chester's. This is Scaleby Moss. Scaleby is not a place that will be known to you, but when you head across to Western Scotland, you go the A69, then you cut across north of Houghton to go to the M6A74. You go past Scaleby Moss. Scaleby Moss is a 2 kilometre by 2 kilometre peat bog. It formed in a depression after the last boulder clay, ill drained. Initially a lake, then sedge and carr, and then peat built up. So there's probably about 5-6 meters of peat in it. It's not one of the largest. Solway moss and Glasson moss would be as large as that. It provided fuel for Carlisle for 200 years. Semi-industrial peat cutting was the main source of fuel for most poor-ish people in Carlisle. But in 1860 something, I think, the local farmer was doing his annual peat cut, because that's pretty much what everybody does in this part of the world. Peat's a cheap fuel, it's on your doorstep. Not just the Irish have a monopoly on this stuff, Don. You know, we did it too. And he was about 2.5 meters down, and his spade went into a torso, and he mangled it a bit, but nevertheless he retrieved it, and there was a skull, a head, and the torso and abdominal organs and part of the brain. And he was dressed in a leather or a skin cloak that had got leather thongs weaving together, and he had a big stout stick across his chest. And the farmer did what all people did. He took it to the vicar because they knew everything. And the vicar called the Carlisle Journal, which is why I know what the state the body was in and everything else, because the reporter was fairly faithful in recording it. And I thought, this is marvellous. Where has it gone? And so I heard it had gone to an antiquarian in Matlock who bought it for 14 guineas. And then it went to the Royal College of Surgeons Museum in London. And then it went to the Natural History Museum. I cracked it, got to retrieve Carlisle's bog body. And then they looked it up on the index card and they said, no, we only have an index. It's actually not in one of our stores at all. The Royal College of Surgeons Museum was bombed in the Second World War and it got burnt. And that's what I felt as well, you know. Believe it or not, this isn't the only bog body in Cumbria. There was another at Seascale, but we have no idea where that happened. But we don't know anything about Scaleby man or woman. We don't know whether he was ritually killed. We don't know whether he died by accident. We don't know whether he was Iron Age, Bronze Age, or even medieval. We do know he was 2.5 meters down in the peat. Has anybody done any pollen work? So there's a brilliant story about how many bogs have we got in this part of the world? Loads of them, and all we're worried about at the moment is retaining the peat and re-wetting them. I mean, should we be looking for more bog bodies? So that really fascinated me, and I went there, and it's kind of hard not to stand there and be moved by it. But that Scaleby had its own Tolland man, and we don't know anything about him apart from what the Carlisle Journal said in 1860 something. So I can't go without this list. So thank you, everybody. Some of the people are in this room. It's an incredibly long list. So don't think for a minute those books, they may contain a few words, but as some famous author said, if you want 10,000 words out of me, you can have it by the end of the week. If you want 200, ask me next year. So all of those people are really kind. And the talk tonight is basically in the book. And the proceeds this time are going to Mind in the Northeast.